In today's episode, we will level up by learning the 3 workflow agents that orchestrate tasks, also 3 communication mechanisms that let agents communicate with each other. By the end of today's episode, you will learn how to structure flows and get your agent talk to each other. And let's get started. The first part of today's episode is workflow agent. So we already know agent can form hierarchy, the organizational chart from last episode. But how do we control the flow of work? That is where workflow agents come in. We have 3 workflow agents, and the first type is sequential agent. They're like an assembling line. So each sub-agent runs in a fixed order. They're passing results along. It is perfect for cases like you fetch data and do the cleaning and analyze and then summarize. The second type of workflow agent are parallel agents. They're like a manager assigning tasks to 3 employees all at once. It is really great for use cases like independent tasks. For example, you're fetching data from multiple APIs simultaneously. And the third type of workflow agent are loop agents. They're like your debug again and again until it works. So loop agent run tasks again and again until a condition is met or meeting the maximum iteration number. The second part of today's episode is how do agents communicate with each other? You know, from last episode, we know hierarchy, and just now we talk about workflow agent. But how do agents actually talk to each other? So ADK gives us 3 communication mechanisms. And the first of them are shared session state. You can think of it as a shared whiteboard. So one agent writes its result and pass it to next agent, and the next agent read it from this whiteboard. For example, an LLM agent can save its output to the state, and another agent can pick it up and read the state output. The second type of communication mechanism are LLM-driven delegation. That is where it gets smart. A coordinate agent acts like a CEO. It will look at the request and decide, okay, which sub-agent should I delegate to? For example, if the request is generate an invoice, and the CEO will route it to billing agent. The third type of communication mechanism are explicit invocation, agent as a tool. Here, one agent can call another agent like a function instead of using it as a sub-agent. So you wrap the target agent as a tool. The parent decides, okay, when should I invoke this tool? For example, a parent agent doing analyze might call a calculator agent as a tool whenever math is required. So you may wonder, what is the real difference between agent as a tool to sub-agent? In this diagram on the screen, you can see the difference between them. To summarize, a sub-agent is part of an organizational chart and is always managed by its parent agent. An agent as a tool is like bringing a consultant. You call them when you need it, but they're not part of your core hierarchy. Alright, let's quickly wrap up on what we talk about in today's episode. We talk about workflow agent gives the orchestration pattern. We have sequential pattern, parallel pattern, and also loop pattern. We also talk about 3 communication mechanisms through agents. We have shared session state, LLM delegation, and explicit invocation. Together, this makes your multi-agent system not just structured, but collaborative and flexible. And that's it. Hi there! By the end of this video, you will learn how to build GraphRAG AI agent with Google Agent Development Kit capable of semantic search, hybrid search, and answering complex questions in Knowledge Graph. Hi friends, if you're new here, I'm Annie. I'm a developer relations engineer. Previously worked as software engineer for 7 years that building production system. Currently, I'm helping developer building AI agent. So this is something I personally really curious about, that how does GraphRAG help AI understanding complex relationship in data? So if you're curious about how to build AI agents step by step in practice, don't forget to subscribe. Alright, let's dive in and start building. Hello everyone, so today let's go through this lab. So if you go to the top right of the screen, you will see the lab link. And this lab is about AI agent with GraphRAG with ADK and memory bank. And for this video, we will focusing on how to build a GraphRAG AI agent with ADK. And this is what's the final result. And you can see that they have the 3D rendering of the final relationship for all the data we're going to play around today. And if you open the camera, you can use your hand to control this graph. It's pretty cool. And at the very bottom, if you ask questions, you can do a search. And here we're going to cover hybrid search, semantic search, and keyword search. Pretty cool. All right, so let's get started. Before I start, you will see that we have some environment set up, and this is skip if you're in the workshop, and this is not. So this lab is actually designed for a Google workshop. But if you're watching this video right now, you don't have to worry too much about it. You just directly start with the step 2. If you're curious about workshop information, you can go to the last page. And here you can see this is a workshop series. You can go from level 0 to all the way to level 5. So it's all the lab related to multimodal agent if you're curious about it. But for this lab, you can actually run it independently, so you don't have to worry too much. So let's get started. At the very first, you need to enable billing account. So here, we're gonna give you $5 free credits so that you can have GCP account set up. And for this whole process, you do not need to put any payment information or credit card. If you ask you to input your credit card, you can just skip that and just claim the $5 so that you have this credit to do this GraphRAG lab. All right, so this is a testing account I have. Let's see. If you open it, you can see we have this way back home data, and you just click here to claim your credit. All right, so here just click accept and continue. Then you will see credit successfully applied. So now you have free credit that allow you to do the rest of the lab. All right, so the second step is to open environment. And here we are opening a Cloud Shell editor environment. This is like VS Code environment, but on cloud. The reason we are doing Cloud Shell is we have this control environment so that everyone can reproduce the same thing. Imagine that if you want to set up on VS Code or different IDE locally, and everybody have a different setup or different operating system, it might be really hard for you to reproduce the same thing, because at the end of the day, you want to reproduce this same cool app with a GraphRAG. So if you want to reproduce this, it's easier to do it in this controlled environment. And this is, as you can see, very similar to VS Code. I'm going to zoom in a little bit so that you can see it more clear. Cool. So now I successfully open it, and those are the steps that just to open the terminal and editor. And you can see I already have this editor and terminal open, so I'm good to go. And the next step is to making sure we have set the project ID and everything. So I just copy this code and paste to the terminal. All right. As you can see, it's saying that I'm currently using this account. Just making sure that the account you're using is actually the account that you're claiming the credit just now. Oh, by the way, if you're claiming the credits, making sure you're using a Gmail account. It doesn't work for your educational account or organizational account. And also, if you run into any error, you can try to claim it in an incognito window. That usually resolves most issues. So let's go ahead and clone our repo. So next step, I want to open this folder. Go to the file and open folder. So here, let's see. So when you open the folder, you might see that you lose the terminal. So you can click the top right, there's to open the terminal. Or you can click this button similar to how you're opening the terminal in VS Code. As you can see that we have this different level. This actually corresponding to our workshop. So this, as I mentioned before, this lab is also designed for Google AI workshop. But if you're watching this video, you can just continue this lab as independent content. You do not have to worry about it. But if you're curious about the lab, this level, each level 0 to level 5, actually corresponding to those folder over here. So you can navigate the code for different level if you're curious about other content. But for this video, we will focus on level 2. So I'll just open the level 2 for today's video. Cool.
And I just finished the second step. Let's go to the third step, environment setup. And here at the very beginning, it's still the similar step. You just open the terminal. And what's next is I want to run the script to init script to set up the repo. So what I do is I copy this, click this, and go to the Cloud Shell and paste to the terminal. So what it does is it's trying to create a project ID for me and attach to the billing account we claimed earlier. And here you can see you can either press enter to create a new project. I already created the ID for you, or you type an existing project ID for you. So it's recommended that we create a new project for this lab. But if you want to reuse some existing project, you can type an existing project ID to use. That's also feasible. So what I do is I just press enter. I'm not entering a 1 or 2, I just press enter, and it will default using this new project. So what it does behind the scene is it's creating this new project for me, and it will automatically link the billing account I just claimed to this new project. And also it's installing some dependency to set up the environment. And now you can see this yellow thing over here. That means I successfully point to the new project I'm creating, and the whole environment is successfully set up. Great. So next step is making sure we config to set the project ID. Actually, in this step, I already set the project ID. I'm just do the step to double check. And then what's next is we need to enable the required API. Just copy paste to enable the required API. And over here, you can see that we want to enable some API platform and cloud build, because later on we might want to deploy the whole things to Cloud Run, because we might want to build the Docker, so we want to have enabled the artifact registry. And here we're using a graph database. So here we're using Spanner. So you want to enable Spanner. And later on, we want to enable the multimodal input, so you want to have the storage API. So those are just the easy way for you to enable some API. Of course, you can also enable them in the Google Cloud Console, but this is just some command line for you to easily enable them. And next, let's run the setup script. Oh, I'm still waiting for it. So while I'm waiting for its enabling, I can talk a little bit more about this project. So as you can see, we're going to build by the end of the lab, and this is actually part of the workshop. So if you follow the level 0 to level 5, you will actually see yourself. You will create an icon of yourself, and you see yourself on a planet. So the theme for this workshop is you're in the universe, you're on a planet, and you want to find your way back home, right? And on this planet, because you want to find your way back to Earth, you're trying to surviving on this planet. So there's a relationship between the people who are among people on this planet. Some people have the skills, maybe they have medical skills. Some other people, maybe they got injured. So therefore, some people, they have the medical skill, can treat the people who got injured, right? So there is a potential relationship between, so my name is Annie, and this is what I'm good at, but this is the resource I have, but I also need something. And maybe if I know how to, maybe if I have some medical skills and someone else need some treatment, so maybe I can help them, right? So there's a relationship on it. That's exactly what is the graph knowledge base we are trying to build later on. So that's a context for this lab, right? So I'm going back to this IDE, and you can see that I successfully enable all those API. So what's next is I want to run the setup script. Just copy this and paste to the terminal. And here, what it does behind the scene is it's trying to grabbing all those environment variable and create a .env file for me and put all the value to the .env file. And here you can see there's a .env file under level 2. So I'm clicking .env file. I can see all those value is grabbing for me, and I have all my environments set up automatically for me. Cool. And what's next is we want to load the sample data by first install the dependency. We copy this and we paste over here. So here we're using UV to do all the environment control. So in the backend folder over here, if we go to the PY project TOML file, you can see those are the dependency we have. So by doing UV sync, we can install all this dependency. And what's next is I want to load all the initial survival data. So I'm copy this and paste over here. So the data we are trying to load over here is exactly the relationship we were talking about earlier. So we have some people are good at medical skills, some people need injured, so they may have the one people's skill may be helpful to another people's need. So there's a match between them, right? So therefore we have a graph relations. We can have a graph database to hold most host data over here. And go back to the thing. As I mentioned before, this is a workshop thing, and we have a survival network challenge. To summarize, the challenge we have is unstructured data. Like maybe people are uploading photo, text message, or videos. And we have complex relationship here because we need to know who has the skills, who need help, and where are they. And then we need to make time-critical decision that we want to match the helpers in real time. And traditionally, to handle multimodal data, we might have separate pipeline, and to search who can help whom, we might do the keyword search. But the problem is, if you search like medic, if the keyword does not exactly match medical training, you might not able to find the person who has a medical skill. So that could be a problem. And relationship-wise, if you're not using graph database, if you're using relational database, like using table, you might have to join the query. So it can be complex and slow. And lastly, we talk about personalization. Yeah, so this is for the whole lab. But for this video, we're only going to talk about the semantic search and relationship. But for the next video, we're going to talk about multimodal handling and personalization. So stay tuned. All right. And so the solution for the challenge is to capture the multimodal processing. We will build a multimodal multi-agent system to capture and to have quickly find the search, like for the helper, we're using GraphRAG. So we're going to cover what is GraphRAG and why GraphRAG. We're also going to cover different type of search in this lab. And then we're using Google Agent Development Kit to orchestrate the whole thing, orchestrate the multi-agent for multimodal processing, and orchestrate the agent with the GraphRAG agent and also multimodal processing agent. And lastly, we have the memory bank for the member part. Again, we're going to cover this in the next video. So here we're using Google Spanner DB to contain this graph knowledge. Traditionally, you might using Postgres and Neo4j, but with Spanner, we only have one unified database so that you have single source of truth and you don't have to deal with the data sync delay. A lot of benefit of using Spanner. And let's get to see what does the Spanner look like. So once you successfully run this command, that is setup data.python, you will see that database setup complete, right? So just over here. So here you can access the database at this link. So just copy this link, click into this link, and you can see we are into Google Cloud Console Spanner over here. And we already load all the data for you. And congratulations, you just finished the step. And let's go to step 4. How to visualize graph data in Spanner Studio. And to follow the step, we go to the Spanner DB, like Spanner DB Google Cloud Console, and at the step Spanner Studio, you click in this, you can see we have all the table that's available for you. And then over here, we have the query input, so we can type anything over here and just do a real-time check. So here, firstly, we want to understand who are there in this knowledge database. We talk about we have different survival on the planet, but who are there and who is where, which part of the planet they're on. So here I'm copy this query just to get a sense of what is the relationship over here. So I'm copy this, I run the query, and I can immediately see the result over here. And here is the graph that showcases the relationship. If you hover on the blue note, then here you can see the survival, and the red note is you can see where are they. So here, by running this query over here, you can just directly see all the relationship. It's pretty cool, right? And what's next is now you understand that we have full survival over here. And what's next is we want to understand what are the skills they have. so that later on you can search the skill and to find a match for the helper, right? So I'm copy this command and then I paste it over here and run it again. Now I can see the relationship is the survival and their skills. So here I have the survival and the skills. Cool. So also we have some explanation in this lab. Again, on the screen, top right, we have this link about this lab so that if you open the link, you can read through the explanation and go through the lab together with this video. Cool. So now we understand we have 4 survival and they're on a different part of the planet and they have different skills. So here we need to understand what do they need. And I copy this query. Again, I go to the Cloud Console at Spanner Studio. Again, I'm going to paste this query over here and I run them to see what are the need. Again, the blue note is a survival. Click to the survival and the red note is a need. Apparently, this survival, they need medical treatment. And lastly, we can see who can help whom. I just copy this and paste it over here. And I can see, wow, I have some existing match. So this person, whose name is Alina Frost, and he has a medical skill, and it has a science skill. And with this medical skill, you can see it's matching those person. This survival, Captain Yuki, need medical treatment. So therefore, Elina's medical skill can potentially help Yuki's medical need. So we already have some match over here, right? So here we can already traverse this graph to understand some relationship and potential match. But as you can see, there possibly could have more match in this graph that later on we're gonna explain how to search them effectively. Cool. So now you successfully finish step 4. And what we did so far is we are successfully loading this data in Spanner DB and we play around this relationship in the studio so that we can visualize the graph here so that we better understanding what's going on over here. We're understanding the relationship of what survival have, where they are, what skill they have, and what the results they have, what they need, and potential and existing match over here. And we can visualize them like this. Pretty cool. We can visualize them as a node and edge over here in this Spanner Studio. So what's next is let's start with the AI-empowered embedding in Spanner. So let's take a look at this diagram on the screen. So a lot of things going on the screen. So let's take a look from bottom and all the way up. At the very bottom, we're most importantly, we're creating this text embedding model and Gemini Pro model in Spanner. And then we have the service layer. Basically, we are using the model we're creating over here and implement the logic in the service so that we can do RAG search, keyword search, hybrid search, and analyze query. And once we have the service layer, like service logic implemented, we can directly use them in the tool layer to building the tools for our agent. So here we can build in the semantic search tool, keyword search tool, and hybrid search tool. Later on, we're going to explain what exactly is hybrid search. And lastly, we're going to use those tools in the agent, like our root agent over here. Here we're using ADK, Google Agent Development Kit to build agent over here. Just a quick recap, what is agent? So agents usually have the model as a brain to choose tools and then use tools to make decisions and resolve some problems for user. And here we're building the tools like semantic search tool, keyword search tool, and hybrid search tool for this root agent. And here are all the logic over here, all the way down here to building this agent. And you may wonder why we are creating the model in Spanner, not directly using the model in the Python code in service layer. Because we could potentially just directly using WordPress AI model in service layer, right? Why we are creating this model in Spanner? So the answer is it's quick and cleaner this way. Because here we are directly creating the embedding for those data in the database, right? So we're using the Gemini model to directly analyze the data. So it will be quicker and cost less if you're directly using the model in Spanner versus you using the model in the service code. Because in the service code, if you're using the model, you have to talk to the database and grab the data, and then talk to using the model as an AI model with the prompt and get a response back, right? So it's additional loop over there. And the question now becomes how we're going to use creating the model in the Spanner Studio directly. And here we are using something called ML Predict. So Spanner's ML Predict let you to generate the embedding directly in SQL. And it can store vector alongside graph data and also perform semantic search. But it's not creating the real model in Spanner. It's creating the virtual model. So it's just a reference, and we don't have to store model weights. And here's a diagram that you can reference. So we can use ML predicts directly in the Spanner. So here we have this input first adds to what has AI embedding model and get this embedding back to the Spanner, and then you can calculate it. So for those of you who don't know what is embedding and what is RAG, to quickly go through them is retrieval augmented generation. And retrieval is so the problem RAG trying to solve is if you directly use AI may not have the personalized knowledge base for your question. So here you may want to use additional database, a personalized database, so that if you link your system to that personalized database, you can do retrieval from the database, and then you retrieve the answer from the database, and then you augment to your existing answer for the final, and then based on that, you can generate the final response back to the user. So basically, you're adding an additional knowledge base to your AI system to make it understand more specialized data, to have more accurate answer, and to eliminate hallucination. So that is usually what we talk about retrieval augmented generation. And the very important part for retrieval augmented generation is usually when we retrieve, we want to generate embedding to do the retrieval. What does that mean is we want to have the embedding, like a numeric representation of the item we want to search for. And then for the database, we want to have an embedding space so that everything in that database, we want to have embedding representation for all of them. So embedding by numeric representation of them. So when you do the search, you're trying to see this mathematic representation, just embedding how close this item I'm trying to search to this embedding space. So if they're very close, that means they're very similar. If they're not very close, that means they're not very similar. So that is the quick overview of what is embedding and why we want to create an embedding here. And just go back to today's lab. We're using embedding. We're creating the embedding model directly in Spanner DB with ML Predict. And ML Predict can create a virtual model in Spanner. It's very quick and very clean. So here, a lot of talking, and let's continue the lab. So what we want to do is we want to create a text embedding for the things we are trying to search, right? So we want to have the embedding model first, and then we can use this embedding model to convert things to the embedding, and then we are doing the semantic search. And now I'm copy this and to the embedding. So here we are paste it over here. And here's a very important thing is you need to replace the project ID to the real project ID. So what I do over here is I'm going to .env file, and I'm copy this project ID, and then I'm gonna paste it over here. So this is how you do it. And if you forget to paste it and you just happen to click run, you may have to, if you forget to replace it, you may have to do drop model text embedding, and then you redo it. Because if you don't drop it, you may not be able to create the model again. So let's go back to the studio and click the run. So here we want to create a model called text embedding. Great, it says successfully created. If you click again, it says it failed because it's duplicated. So that means it's already created before. Cool. So if you click twice, if you see the fail, that's expected because you already created earlier. And what's next is we want to add an embedding column. So we are copy this and we're gonna paste it over here and click run. And here we successfully create a skills table. So what we want to do is we want to search skills and we want to create an embedding space. So basically we want to convert everything in the skill table to skill embedding. And this is how we're going to do it because we already have the model and we can create a text embedding for all the skill in the skills table. So here we have 10 row updated. So basically we update them to be embedding so that we can use semantic search over here. Again, if you see the permission error, you might have to redo the previous step to drop the model and then recreating the model text embedding with the correct project ID. And now let's verify embedding by copy this and then go back to the Spanner Studio and we're going to paste it. Cool. So you can see that we can see all the skills available over here with the embedding. We have the embedding dimension over here is 768. That means we're using 768 dimension to describe the skill over here. So that means we are successfully convert all the skills to embedding in this embedding space. Great. So last thing is we want to test the semantic search. So just copy here and paste and just run. And you can see we successfully do the semantic search. What we're trying to search is we're trying to search medic. As you can see, when we search medic, it's not medical. It's if you use a keyword search, you may not able to find a result for those things that are similar to the meaning of medic. Then because you are converting them to embedding, and here you actually get the meaning of medic. And then you're searching in the skill table, you just like a skill, you're searching this embedding representation of skills. So here you're searching the embedding space and you're trying to find how close they are with the call sign. You're using the call sign to calculate the distance. So basically the smaller the distance they are, that means the similar they are. And here you can see the medical training is actually the most similar to medic, and leadership probably not as similar to medic as a medical training. So here we are ranking them by the distance, and this is exactly what we're called semantic search earlier. And this is for when we do the retrieval. This is how we want to retrieve things. Cool. That means we have successfully do the semantic search over here. What's next is we want to create Gemini model to analyzing. And the Gemini model, we want to using Gemini model directly in Spanner Studio. A Spanner as well. We just like what we said earlier, we want to using Gemini Pro model over here. So similarly, we're using ML predict to directly using the Gemini model. And this is what we want to do. We want to copy this and paste it. So here I did it wrong because I didn't replace the project ID. So what I want to do here is I want to drop this model first and then run it to drop this. And then I want to recreating this with the correct project ID. So here I need to go to the editor and here I have this project ID. Just copy this and then paste over here so that you can run them. And here I successfully create a correct Gemini Pro model. And what's next is I want to use this Gemini to analyze and generating things. So I'm copy this and paste over here. Let's take a look at what this query does. So here I'm actually sending this prompt to the Gemini Pro over there. So this prompt is, I want to access those two survival, and this is a survival name, and I want to generate a score from 1 to 10 and one sentence reason. So I directly sending this prompt to what is AI model over there, like this Gemini Pro model over there. And with this question, I generate this answer. It says, oh, I'm generating this score 9 over 10 and with this reason. So that means you're successfully using the Gemini Pro model. Again, you can see if you have the syntax error message, you can ignore them because the result here is correct. Cool. So at this step, that means you have successfully creating the model, creating the embedding. Just to recap what we did before, we create this text embedding model. We also create this Gemini Pro model in Spanner. And you also did is you're using this text embedding model and try the semantic search in Spanner because you're converting the skill to embedding space. And then we try to search MEDDIC in the skill embedding space, and we can rank the result by the distance for the embedding, and then we can rank how similar they are to the things we're trying to curate. So that's what we just did for that step. And congratulations for those who have finishing that step. And the next step is now we are having this model in Spanner, and we also get a taste of the semantic search in Spanner DB. And what's next is we want to directly use them in the service layer so that we can implement the service layer logic. And later on, we can connect the agent to the service logic. So here, I'm going to step 6, GraphRAG. So in this step, what we're trying to do is we are trying to implementing the semantic search logic all the way from service layer to the tooling layer to the agent layer. And here we are using ADK, Agent Development Kit, for the agent. So if you don't know what is ADK, I will do ADK doc Google search. And on the first result, here is the ADK doc page. And here I can learn everything about ADK doc. You can get started with ADK and build your agent. So I will go to the agent tab and try to understanding those are different type of agent and just get familiar with this framework. So let's go back and trying to implement our semantic search in the GraphRAG agent. Excited? So now you're actually building a GraphRAG agent over here. Cool. Let's copy this to the terminal and paste it over here. So this step is basically opening this file for me in the editor. And here I'm opening this service folder. So I'm trying to do the implementation in the service layer. And what I want to do is I just need to copy paste the important logic. So I'm searching this to do replace SQL code, and I'm going to paste the whole thing. And I need to replace the whole line by I triple tap this. So it's selecting the whole line, and I paste it so that the indentation is correct. And let's take a look at what we're pasting over here. So here we actually is very similar to the query we just run in the Spanner Studio, right? Because we're using the text embedding model we created in the Spanner, and we're trying to find the cosine distance for the skill embedding space. But you can see that we actually have more things over here. We actually have the join table over here. And what does that mean? So here is what we call GraphRAG kick in. And let's take a look at this diagram. So this is the overview of what we're trying to do, like the GraphRAG process. So in our example, we're trying to find MEDDIC for burn victim. So we're searching MEDDIC for burn victim. And then I'm trying to see who can help MEDDIC, right? So here we have this embedding model created in Spanner Studio. So what we did first is we're creating this embedding of this MEDDIC so that we have this numeric representation of MEDDIC, right? So next is we're trying to search in the embedding space and find the things that physically close to MEDDIC. And the importance of GraphRAG, the difference between GraphRAG versus traditional RAG is we actually do this LLM context in the graph context so that you can traverse this graph to understand more information. So you're not only understanding what are the skills that's similar to MEDDIC. Previously, we get medical training that's similar to MEDDIC. We also get the corresponding relationship of we can traverse this graph to understand what are the relationship connecting to the skill. Who has this Dr. Frost has the skill of medical training so that it's able to understand. We traverse the graph and get more content for this query so that you can give more related response to your question. And this is really powerful. And in our code, is we are trying to join this table is basically how we want to traverse the graph node to get more related information over here. And if you're curious, you can read more explanation over here in this lab. Again, the lab is on the top right of our window. Now let's continue to building the tool. So what we did before is we're creating the service layer. Now we want to connecting the tool layer to the service layer. And again, we're just only working on the semantic search. So I'm copying this, paste. So I'm opening the tool file. And over here, I'm locating the comment. I'm going to paste it over here. And I'm going to triple tap and selecting the whole line. And I'm copy this and I'm pasting this so that I'm creating this tool called semantic search. And over here, I'm using the logic that I implemented in the service layer. Again, if you're curious about the source code and you want to understand more about the logic, I recommend you to go to the top right link and open this lab, and you will see the source code over here to understand more about the detailed logic behind the scene. Let's continue. So now we have the tool, and we want to connect in the tool to the ADK agent. So here, I think a basic agent code. So here is a basic agent code. Over here is with ADK, you just need to using the agent library and define what model you're using, what is the description, and then adding the tools over here. We're supporting Python, TypeScript, Go, and Java. And I'm copy this to do and replacing. Oh, I skipped a step. I need to go to the agent file first. So I have the agent file and I'm searching this. So here I am copy this to the prompt. So what I'm trying to do is I'm adding this semantic search logic in the agent instruction so that in the agent instruction, it knows when to do the semantic search. Cool. And lastly, we need to add the tools we just we're connecting that to the agent. So the agent, the brain, model as a brain to select the tools we're provided to the agent. So what we want to do is, again, we want to search this. I'm going to paste it and just paste. And here we go. We're adding these tools to the agent. And now, congratulations, you're just successfully building a GraphRAG agent. And now you may say that, oh, here is some reading for you, understanding how the hybrid search works. So what we did before is we are implementing semantic search for RAG agent. So semantic search is we're getting the embedding and we're trying to find things that are actually similar to the meaning of the things we're trying to search. So the keyword search is we're searching the exact text matching word. And semantic search is we're trying to find the things that are similar. But what if we want to search medical skills in mountain? We want to find things, we want to search for things that are similar to medical skills, but also we want to have the exact keyword search for mountain. So here, what if I care both? How do you do the search? And here we are introducing this hybrid search with the RF algorithm so that we can do the fusion for both type of search. And this is the algorithm behind the scene. Is with the keyword search, we have this ranking, and with the semantic search, we have another ranking. And then we are using this RF scoring algorithm to calculate the new score. And then we get this new ranking. And then we find the result that it's a good match. It's a good combination for the two types of the search. And if you're curious about exact logic, you can go to this file and then the hybrid search. When the hybrid search is called, we are implementing this logic over there to calculate the ranking. And those are some readings for you that if you're curious about when to use what kind of search. Cool. So just to summarize of what we've done so far. So to summarize what we've done so far is we're creating the embedding model and Gemini Pro model in Spanner, and we're implementing the related logic in the service layer. And then we're connecting the service layer, the semantic search logic to the semantic search tool. And then we are use this tool all the way in the ADK agent. So here we are creating the GraphRAG agent with semantic search. We're also understanding what is the difference between the GraphRAG search versus the traditional pure RAG search. We're also understanding hybrid search with a new algorithm like RF algorithm, so that we can combine the result for the keyword search and also semantic search. And what's next is we want to test our agent with ADK Web. And to do the test, we just first copy this and then gonna paste it to the terminal. So if you take a look at this command we're typing, what we actually care is ADK Web. So ADK Web is a command to open the ADK Web UI that we can directly interact and troubleshooting and have the observability for the agent we're creating. If you want to learn more about the ADK Web, you can find more with the ADK Web doc in this link over here. You can see how to use the ADK Web and a different way to start ADK Web with different language over here and more. So now if you're doing ADK Web, you're just clicking on this link so that we are open up this ADK Web. And on the top left, you can select the agent we're creating and you can asking some question. For example, who can help with injuries? And according to this, we're expanding it to using semantic search to find the person who has the medical skills to help with the injury. So here you can see I can help with we can try to use semantic search. If you have on it, you can see those are all the tools that connect into the agent. And this is the result for using these tools. And this is finally LM generate this result, say, oh, those. So we have David Chen has this first ad, and we have Dr. Elena has the medical training and more. Pretty cool. So you can see the tracing over here by when it is executing the tool. So you can see is that the time we're executing the tool and how long the latency, how long the duration for we to calling LLM. So it's a really cool way for us to do the troubleshooting. Once we finish all the testing, we're going to do the Control-C to end the process so that we can continue more testing. So the next step is we want to run the full application. Remember the cool UI we had earlier, like this cool UI? So to do that, we want to actually run the full application. So what we did earlier is we're creating the root agent and then we're connecting it to the tools. So now we want to connect the backend to the front end. And in this case, we have the front end, the browser, and the React component. So the backend, we have the ADK agent. And then we're using fast API for the API layer and in the file called chat.python as a router in this lab setup. So here's our important concept over here for us to understand how exactly we connect in front end and back end. And here's the concept of runner and session service and memory service. So runner basically a power up agent. So for agent, we have model as a brain to choose the tools we want, right? And each time when we model is making a decision to choose a certain tool or we're using this model, they're all different events. And for those events to continue, we need an engine to power up them to have this event loop. So that is where a runner play the role. So we have this runner to power things up to grab this event so that in this API service, in this API layer, we're gonna pass the input from the front-end UI, and then we're gonna through this runner power the event, we're gonna send it to the agent, and then finally we get the final response. We're gonna pass the response from the final response for the agent and send it back to the front-end UI. We also have session service and memory service. So those basically contain the conversation history we have with agent. So whatever you're talking to the agent, you talk to the agent, say, do this search, or who has this medical skill? You're asking information about this relationship, to understand more about this knowledge database. All the conversation you have with agent is stored in the session service and memory service. So now we are at chai.python file, and then what we do is we copy this to do, and we're gonna paste it over here. As you can see, this step is we're creating the session service, the memory service, so that it can store the conversation we have with agent. And so for ADK, we have 3 different types of session service. And here we're using in-memory session service. So for in-memory session service, if you refresh the page or turn down the machine, it store all the conversation stored in the RAM. And then when you reopen the machine, you will lose the conversation data we have. And in the ADK doc, you can take a look at session service. Cool. So here we have in-memory session service that store all the data directly in the application memory. We also have WordHas AI session service that can store things like using WordHas AI infra via API call for session management so that it can scale on cloud. We also have database session service that it can connect to relational database or different type of database for a persistent data. So if you store your information in a database solution or in the WordHas AI solution, it can potentially scale and store long-term information. But right now in the lab, we are using in-memory session service. Cool. So now we have the session service. We need to replace the runner. We'll go here and search the runner, and we'll copy this to the runner over here. And you can see we'll attach the session service and memory service we're creating in the runner over here. And if you want to know more about runner, you can also search runner in the stock to see the runner role, the orchestrator, and understand more about runner. Cool. So now we're just implementing this important piece, runner, session service, and memory service in the API layer so that we can connect the front-end React component to the ADK agent we're creating over here. And let's give it a try to see the final response. So we just copy this, and then we paste it here, we paste it over here. So what we did over here is I'm actually using a script, start app.sh script, to help you quickly start an application. But essentially what it does behind the scene is it first start the backend and checking the port with the 8000 port to spin up the server. And then it's using, so you can see that we have the service running on 8000 port. And then what's next is we want to using npm install and npm run dev to start a React frontend. If you don't run the script, you can run the backend and frontend separately. But here we are running them so that it's easier for you to start the app. So here we can see we have the local host, we're just clicking them. And now we expect to have the application working. Cool. So you can see that it's actually have the application. I'm going to say allow it. And you can see I can controlling this app. It's pretty cool, right? And what's amazing is those relationship or those 3D graph you're seeing over here is actually the 3D rendering of the Spanner Studio, the data you saw in the Spanner Studio. So this is a 3D version of all the relationship we have so far. For example, if you click into the notes, for example, over here, you can have the survival detected, and this is the information over here. And now let's go to the lab and try to ask the question. For example, find skills similar to healing. Just copy this, paste it. So what happens behind the scene is in the chat.python file, the fast API layer that we are asking this question, and we put this question to the ADK agent, and ADK agent gonna return the response back to the user. Now, if you see this unexpected response, service account information missing the email field, if you see this response, that's very likely happen to you because now we're using the Cloud Shell environment and it will time out every other 30 minutes. So your token will expire for the security purpose. So all you need to do is just like me refresh this whole page to refresh so that we can refresh our token, and we should solve this problem. So I'm gonna click this open terminal. I already opened it, so I will refresh the page to see does that resolve the problem. And let's copy this and paste over here. As you can see now, we find the response. It will find the skill similar to the healing, and it is using semantic similarity like RAG search. What we did is we successfully create the GraphRAG agent with the ADK and spanner, and then we connect the front end and back end with fast API. And now when you ask anything in the chat, you can directly find the result in the spanner from the spanner knowledge base. Very cool. So you can also test different search and get the result.